The book that I'm going to review today is one that I got back in 1991. It is another computer book, but this one focuses on computer organisation. Now, the book that we're going to look at is called Principles of Computer Organisation, a first course using the 68000. So let's crack on and review Principles of Computer Organisation. Now, this is an older book. I think it was 1991 or 1992 that I got this. And it focuses on assembly language, and it uses its own machine called Papyrus in order to describe a generic type of assembly language. But it also looks at the 68000, that's the Motorola MC68000 assembly language, and makes a comparison. So it's really quite good in the fact that it introduces the ideas using its own little machine. So there's only, I think there's about 230 pages or so on it. Okay, so it's not a huge book compared to the books that I have already reviewed. So let's have a look through and we'll see what's in the contents. So, Chapter 1, Elements of the Computer, and again I'll let you read through these for yourself. Instructions and their execution. Arithmetic and control. Data types and addressing. Subroutines and program structure. Input, output and interrupts. The architectural level in its context. And there's also an appendix with a summary of the 68000 instruction set. So you'll notice that there's certain sections of this book underlined because I have actually obviously worked through lots of it. So the first chapter here focuses on the elements of the computer. So just a basic model of a computer, and you'll have seen this one before: architectural model, system software, the programming interface, application software, the user interface. Now again, some of it is a bit dated, but a lot of it still remains relevant. It goes through high level, low level programming, the von Neumann model, and just some real basic stuff about your computer. Talks about the memory and memory structure. And again, the computer that it generates here is a 16-bit machine. Now, it introduces a computer which is an imaginary computer which is generated in order to describe organisation. So the imaginary computer is a paper computer, so they've called it Papyrus. And there's also an introduction to the MC68000. So that's a basic introduction. Now the book starts in earnest. So in chapter 2 we look at instructions and their execution. So we're looking at ideas of registers and memory, a function and an operand address, and how instructions are actually executed. And it's got nice little examples here of adding numbers together, and it's got the basic commands here: the load, add, sub and store, in order to produce this little algorithm. And then it goes through the fetch, execute, and then the decode and the actual running of the instruction. So it introduces the idea of a fetch execute cycle, the program counter, memory data register, and it goes through examples of how the information is passed between the registers and the memory in order to work your way through a basic algorithm. And it's got nice little diagrams here as well, which are always really helpful, especially when you're learning this stuff. And then it's got the basics of writing a simple program, and you can see by all of the underlines here how much this little section, how much value it was to me. So we'll look at declarations and directives in terms of your assembly language, and also labels. We look at an example program here as well, and you've got a little example program here in high level language, and then the equivalent in the Papyrus assembly language. And the nice thing here is you can pick up a basic structure of the assembly language, and from this you could generate a basic assembler. So I'll crack on because I'm going through every single page here. We get through bits of other information about long instructions. It moves on at the end, so the last section in every chapter is based on the 68,000. So it goes through the 68,000 registers and instruction set in this little section here, or it goes through some of the instructions, and it goes through an example 68,000 program. So this is the actual 68,000 program that would perform the program that we've seen just earlier for the imaginary machine. So that's the nice thing, because there's this nice juxtaposition between the actual code that will run, and you could take this and put it through an assembler and you could get it to run, and you can compare this to the code here which has been generated for the imaginary machine. Now the next section is arithmetic and control, so it basically goes through the arithmetic operations, negative numbers, carry overflow, status bits, and the addressing modes, so immediate operands, program control instructions, so jump instructions, so just the basic instruction types, conditional jumps, program loops, and again it gets through this example here of using a little label here in order to generate a loop so that we can jump through and iterate through programs, program execution, program tracing, a little bit about program tracing here, execution, monitoring, dry running, hexadecimal notation, and again it goes through the last chapter how arithmetic is done in the 68,000, so arithmetic commands like multiply and divide, so on and so forth. So this is all the 68,000, some of the instructions. Okay, so that's the end of that chapter there. Now the next chapter here, data types and addressing. Now it covers the different types of data types, so for example real numbers, integers, floating point representation, characters, and how we operate on characters, and a bit about truth tables here, logical instructions, so the and, the or, and the not, and the shift, and arithmetic shifts. And this section here, it talks about arrays and memory referencing, so how can we reference values within an array and the type of commands that are needed. And then it moves on to talk about indexed addressing, and the nice thing is it's got nice diagrams here for the different types of addressing modes, and it works through some of these addressing modes in this section here. And you can see here it's got absolute and relative addressing, indirect addressing, pointer structures, and how to access two-dimensional arrays. There's two-dimensional arrays here, which is really quite handy. And there's a summary here of addressing modes with a nice little diagram of the different types of addressing modes. So, and it also goes through, as I say, the very last section of each chapter covers the 68,000. So we go through some of the addressing modes in the 68,000. So the next chapter here, subroutines and program structure. So we look at how we can go in and out of subroutines using the jump to subroutine and return. And we've got little programs here, an example how we can use it. And we then look at the stack and how we can use the stack in order to jump in and out of nested subroutines. And this shows how the stack operates. And we look at how we can pass our parameters. So we're looking at passing variables into our subroutine. And this is a nice little section because it shows you how to simple value parameters, passing parameters by reference, and it also goes parameters in the store and using stack in order to pass parameters. And that there looks like I've spilt tea or coffee on it. So again, some nice programs here with the push and the pop command showing how we use the stack. And also we look at recursion, so a little factorial recursion program which I have actually used and built into my own machine, and stack based storage as well. So a nice bit on stack and also bits on macros and a bit on the structure of machine level programs, relocatable code, and again the 68,000 section for subroutines and the stack with actual programs. Now the next section, I haven't covered an awful lot on it, but we'll talk through and we'll have a little look through it. So input, output and interrupt. So memory mapped input, output, which is what I use on my machine, and how we talk through the bus to each of the different elements, device polling, and also a nice section on interrupts and enabling and disabling interrupts, character input using interrupts, and the interrupt vector tables. And it shows you how the interrupts are dealt with and with the 68,000. And we're nearing the end of the book now, so this is really the 68,000 section. Now the very last chapter here, we've got a bit here about exceptions, okay, as well, which is quite handy. Now the very last chapter is the architectural level. I think this is kind of added in as an afterthought, okay, so there's just a little bit about logic elements, okay, and a bit about software. And the last word on the 68,000, so another little bit about the 68,000. And we've also got a basic instruction set summary for the 68,000 here, which is quite a handy thing. And a nice little index at the end. So it's an excellent little starter book, and I have actually taken some of the code that's in the book and I have implemented it within my own CPU. So that's all for this book review. Thank you for listening. I'll get you on the next video. Goodbye.